Let's imagine you're standing in shallow water on a tropical reef, ankle deep, maybe knee deep. The water's warm, it's clear, and you can see straight down to the sand. Nothing around you looks dangerous. No fins circling, no shadows lurking. Just a few pretty shells scattered across the seafloor. You reach down and pick one up because, well, it's a nice shell, and that decision might be the last one you ever make. Because that shell isn't empty, and what's inside it doesn't need size, speed, or teeth to kill you. It just needs about 3 seconds and a straw sharper than a hypodermic needle. This is the cone snail, and despite looking like something your grandmother would put on a shelf, it might be the most efficient killer in the entire ocean. When people think about ocean predators, they think big, sharks, orcas, giant squid, creatures that dominate through raw size and power. But size actually comes with a cost. Big predators need big meals, they burn massive amounts of energy just existing, and most of their hunts fail. A lion misses more than it catches. A shark spends most of its life just cruising, not killing. The cone snail doesn't have that problem. It's slow, it's soft, it has no claws, no jaws, and it moves at a pace that makes a garden slug look like a sprinter. And yet, when it decides to kill something, its success rate is close to absolute. Nothing it targets gets away. Nothing. So how does an animal with zero speed manage a perfect kill record? The answer is a weapon so specialized that scientists are still trying to fully understand it. Inside the cone snail's body is a modified tooth, except calling it a tooth undersells what it actually is. It's a hollow, barbed harpoon, and it's loaded, cocked, and ready to fire before the snail even knows what its target is. When a fish swims too close, the cone snail extends a long, flexible tube called a proboscis, and it can smell the water for prey using chemical receptors, essentially tasting its way toward a meal it can't see coming and definitely can't outrun. Once the proboscis is close enough, the snail fires the harpoon directly into the fish's body. This whole exchange happens in a fraction of a second, faster than the fish's nervous system can even register a threat. But the harpoon isn't the real weapon. The venom is. Cone snail venom is one of the most complex venoms in the natural world. A single sting can contain over 100 different toxins, called conotoxins, and each one is precision-built to shut down a specific part of the nervous system. Some block sodium channels, some block potassium channels, some target the exact receptors responsible for muscle movement. It's not a general poison. It's a coordinated chemical assault, engineered to make sure nothing goes wrong. For a fish, the result is instant. We're talking full paralysis in under a second. The prey doesn't have time to swim away, doesn't have time to struggle, doesn't have time to alert anything nearby that a predator is even present. One moment it's swimming normally, and the next its entire nervous system has simply been switched off. This is why scientists sometimes call certain cone snail species nirvana cabal hunters, describing venom cocktails so effective they induce something close to a trance before death even happens. The prey isn't just killed, it's shut down so completely and so quietly that other fish nearby don't even register a threat occurred. Compare that to literally any large ocean predator. A shark's hunt often ends in a chase, a thrash, blood in the water, other predators showing up to steal the kill. An orca sometimes spends hours coordinating an attack with its entire pod just to bring down one whale calf. All that effort, all that energy, and there's still a chance of failure. The cone snail spends almost no energy at all. It doesn't chase, it doesn't fight, it waits, it senses, it fires once and it's over. But here's the part that should really worry you. Some cone snail species don't even wait for prey to swim close enough for a direct hit. The geography cone, one of the most dangerous species, can release its venom into the surrounding water itself, essentially turning the entire area around it into a paralyzing zone. Fish don't even need to touch it. They just need to be nearby. So if this thing is such an efficient killer of fish, why should you, a human being roughly 10,000 times larger than its usual prey, actually be worried? Because the venom doesn't care how big you are. Conotoxins don't work by overwhelming mass with volume, the way a snake bite might rely on quantity. They work by hijacking specific ion channels in your nervous system, the same exact channels a fish has. And human nerve cells use the same basic wiring as fish nerve cells. If the toxin can shut down a fish's ability to move, it can shut down yours too. Size doesn't save you here. Biology doesn't discriminate. There is no antivenom for cone snail stings. None. If you're stung by one of the more dangerous species, like the geography cone or the textile cone, the venom starts working immediately. Numbness spreads from the sting site. Then comes muscle weakness. Then, in the most severe cases, paralysis reaches the muscles that control your breathing. And that's the part that actually kills people. Not the sting itself, but suffocation from a body that can no longer move. Divers and shell collectors have died from this. Some have described it as barely feeling like a sting at all, more like a tiny prick, easy to shrug off as nothing. Right up until the numbness starts climbing up their arm. And here's the part that makes this even more unsettling. The cone snail isn't hunting you. It has zero interest in humans. You are not on its menu, you're too big to eat, and it gains nothing from attacking you. Every human death from a cone snail has been purely defensive. A snail that felt threatened by being picked up, poked, or handled, and simply used the exact same weapon it uses on fish. This is a creature that evolved a perfect, silent, undetectable execution method for something the size of a minnow, and that exact same system happens to be lethal enough to take down something the size of you. So why doesn't every fish just avoid cone snails if they're this dangerous? Because they can't tell what they are. Cone snails don't chase, they don't lunge, they don't display any warning behavior. They sit motionless on the sand, indistinguishable from any other shell, until the exact moment they strike. Evolution built the perfect ambush predator by making sure the ambush never looks like a threat until it's already too late to matter. That's the trade-off with size in the ocean. Big predators broadcast danger. You can see a shark coming. You can hear an orca's clicks. You know something is wrong before it reaches you. But small, quiet, specialized killers don't broadcast anything. There's no warning system for something that looks exactly like a rock. And this isn't just a cone snail thing. It's a pattern that shows up again and again in the ocean. The blue-ringed octopus, barely the size of a golf ball, carries enough tetrodotoxin to kill multiple adult humans, and it has no antidote either. Box jellyfish, nearly invisible in open water, can deliver a sting so severe it can stop a human heart in minutes. In every one of these cases, the animal isn't relying on size, speed, or strength. It's relying on precision. Because in evolutionary terms, efficiency beats power almost every time. A predator that spends less energy per kill and fails less often will always out-survive a predator that relies on brute force. The ocean has been running this experiment for hundreds of millions of years, and the smallest, quietest killers keep winning. So the next time you're wading through shallow water on vacation and you spot a beautiful little shell sitting on the sand, maybe leave it exactly where it is. Because down here, the biggest threat was never the thing you could see coming. It was the thing sitting perfectly still, waiting for you to make the first move. Thanks for watching. And if you want to see the video about why the ocean's deadliest jellyfish isn't the one you'd expect, check it out here.